Alright, let's look at section 9.1 now. In this section, we're going to start jumping into what it looks like when you multiply and divide rational expressions. You're like, what the heck is a rational expression? Let's go to the notes real quick. I just want to show you what that specifically looks like. Rational expression is just it's just the difference or the ratio of one function over another. It's a fraction. So 3 over x is an example of a rational function. X squared minus 1 over x minus 1. Z cubed minus 3z all over 3xyz plus 1. These are examples of rational expressions when we divide one expression by another expression. So here is, I have a couple examples here in the notes. I'm going to walk through them real quick. And again, this is just as a reference guide for you. We're going to still go through some examples, but I just want you to have something in your hands that you can look at in case you need just a little bit of guidance. So here's a quick example. If we have to simplify 9x cubed over 12x to the fourth. So what we did in the last chapter is we worked on factoring and kind of breaking each of these individual components into their smaller pieces. So just multiples of smaller pieces. And so that's really what we're doing. We have 9. 9 breaks up into 3 times 3. And then the x's all just multiply out times each other. A little interesting side note, actually. Before Isaac Newton and Gottfried Leibniz. You've probably never heard of Gottfried Leibniz. You probably have heard of Isaac Newton. Isaac Newton was one of the most prolific scientists ever. He wrote a lot about physics. You might have heard of Newton's laws of physics and gravity. So he came up with those, but he also helped or was a co-founder, I guess co-discoverer, if you want to call it that, of calculus, which is crazy. Now, simultaneously when Newton, this is in the late 1600s, discovered calculus, there was another person in Germany who discovered it kind of simultaneously. And back then they didn't have a whole lot of correspondence. It wasn't revealed until probably months or even years later that they both came up with the same discovery at the same time. And so most of you have heard of Newton. You probably haven't heard of Leibniz. And the reason why Leibniz is important is because all of these exponents that we have, most of the modern mathematical notation or the way in which we write math was developed by Gottfried Leibniz. And so prior to that, this right here was how they wrote multiplication of variables out. They'd write x times x times x. Leibniz said, hey, why don't we just put a number as a superscript and we'll call that x to the third. That's just x times x times x. So that's a little math history for you right there. There's a lot of crazy math history stories, and if I have any of you in future classes, I'll be sure to tell you a few. There's love and intrigue and people dueling over women, and it's pretty it's pretty intense. I'll just put it that way. So. Alright, so here we go. We break these up into our individual components. We've got 3 times 3 times x times x times x. That's 9x cubed. And then down below, the 3 times the 2 is 12. And then 4 x's multiplied out. So what we're doing is we're just going to cancel things out. So if there's something on the top that exists on the bottom, we cancel it. So the 3 cancels with the 3. There's 3 x's up top. There's 3 x's on the bottom. We can cancel them out. And then what we have remaining is our solution. So there's only a 3 left in the top, so that comes over here. And then the 2 times the 2 is the 4, and we also have an x left over, so that's where we get the 4x. So this is our answer. 3 over 4x is what this right here actually equals. All right, so now what do we do when we multiply rational expressions? Well, If we have these expressions, again, I'm just using a letter to represent an entire expression. All you do is you just multiply right across. So a times c in the numerator, and then b times d in the denominator. So here's a quick example. Let's multiply 4 times a squared times b cubed times 25 times x cubed times y. Okay. So what we'll do is we will go in and just let's first multiply the coefficients. So the 4 times the 25, that's going to be right here. And then all we do is we just merge all of these variables together. So we get a squared, b cubed, x to the third times y. Now the same thing happens in the denominator. 15 times 16 is going to be right here. And then again, we just bring everything along for the ride. And I changed the order of it. When you multiply, you can change the order of the variables. I personally prefer putting them in alphabetical order. You can do that. It doesn't really make a difference because everything will cancel out in the end. But sometimes when you put it in alphabetical order, it's a little bit easier to spot what's going to cancel and what's not going to cancel, and just keeping track of everything. So I usually just put it in alphabetical order. So now we just multiply the coefficients out, and we got 100 times a squared b cubed x to the third times y over 240 ab x to the fifth y squared. Okay, we're not done. We can still simplify it. The first thing that we do is we're going to simplify the 100 over the 240. We can actually reduce it down even further. One of the things, and I was going to include a note here, and then I'm like, you know what, it doesn't really work in this example, but I generally prefer doing it. What I'll try doing is if I notice that these right here are even numbers, I'll try dividing everything by 2. I'll just keep cutting them in half. So 100 over 240, that's the same as 50 over 120. You can cut it a half again if you want. So that would be 25 over 60, right? And then you can't do it anymore because 25 is not an even number. Now you could do that. Another thing to do is notice how there's this is 100 and 240. You can actually just knock a 0 off the back of both of those, and you'll get 10 over 24, and then you can divide it by 2. So I did it a little different down here. I divided by 2 and then divided by 10. You can divide by 10 and then divide by 2, and you'll still get 5 over 12. So we're just reducing this 100 over 240 down into a smaller fraction. Or it's an equivalent fraction, it just has smaller digits in the numerator and denominator. Then what we do, we look at the variable part. The a's, the b's, the x's, and the y's. So there's one of the properties, if you remember back in 7.4, there's properties of exponents. And the properties, if you recall, if you've got an exponent of a variable in the numerator and an exponent of a variable in the denominator, you actually will subtract them in the exponent. So here we've got a raised to the 2 minus 1 because I've got this guy right here, that a. Again, I didn't have the exponent up here. I just added it just for you can see exactly what it is that you're subtracting. The b to the third is in the numerator, so that's going to be the starting point, and we're subtracting what's in the denominator. X to the third is in the numerator. This is going to subtract to what's in the denominator. So 3 minus 5. Y to the 1 minus 2. And now we just do our subtraction. So now we've got a to the first. 2 minus 1 is just going to be 1. 3 minus 1 is going to be 2, so that's b to the 2. 3 minus 5, this is where it gets interesting. That's going to be a minus 2. And then I've got y to the 1 minus 2. That's going to be y to the minus 1. Now remember, when we've got negative exponents, what does that mean? That means that we can bring that down into the denominator and change the sign. So this becomes a to the first, b to the second, because these are both positive. The exponents are positive in these pieces. And then for this part here, because they have negative exponents, that means I can flip the sign and bring it into the denominator, and now I have positive exponents. So now we just combine the number, the numerical part, and the variable part, and what we get is going to be 5a times b squared divided by 12x squared y to the first, or times y. So that's how this one works out. Again, this is just an example for you to reference when you are working on some of these problems. Now, how do we divide? Dividing, it looks really scary, but the way I like thinking about it is just flip and multiply. Multiplication, we just did it above. It's a lot easier than dealing with dividing. If you take a fraction and you divide another fraction, it's just like, wow, how does that even work? Well, the way it works is that we can, like I said, we know that multiplication and division, they're actually inverse. The fancy term is inverse operations of one another. So what that means is that I can flip the numerator and denominator around and then change the sign to multiplication. That works totally with the rules of math. So now that's only going to be the part that is being divided by. So the part on the right-hand side of the division sign is the part that's going to flip. So here's what we got. X plus 4 over x, that's the first part, divided by x minus 2 over x. That equals, now the first part's going to stay exactly the same, and the second part, we're going to change it to a multiplication, which is why I've got the dot here, and we're going to flip the numerator and denominator around. So when we combine everything together, again, we're going to multiply across the numerator and we're going to multiply across in the denominator. We get x times x plus 4. And again, the order doesn't matter. You can do the x plus 4 times x, the x times the x plus 4. It doesn't matter. It's multiplication. Now the same thing with the denominator, x times x minus 2. Now one of the common things that a lot of people will probably do is they'll say x times x, that's x squared, and then they'll just bring the 2 along. You can't do that. The whole thing, x right here, has to be multiplied by the entire thing. So that's why we write this whole thing out right here. So now we can go in, and just like we did above, we can cancel out what is common between both the numerator and denominator. There's an x in the numerator, an x in the denominator. We can cancel those out, and we're left with just the remaining pieces. So that is an example of dividing a rational expression. Now I'm going to go through a few questions here. There's a few of them that are a little long, and so I want to just walk through them, because I really think that if we get a grasp of this, it's going to help us immensely just with our as we progress forward into some other classes. Okay, so let's take a look at question number 22. This is out of the textbook. This is asking us to do a squared plus 4a over ab plus 4b. Now what we're going to do in most of these problems, just going to let you know, is we're going to factor pieces out of these expressions. Now why are we doing that? Because when we do that, we'll likely find that things will cancel out. So we can reduce it down into its simplest form. Okay? So usually when I look at questions like this, what I'm going to try to do is I'm going to try to spot what is common between both pieces in the numerator. I'm only going to do the numerator first. I'm only going to do the denominator second. Okay? We'll just look at the numerator first. There's an a squared in the first part and a 4a in the second part. So that means that there's an a actually in both of these pieces. So what I can do is I'm going to pull an a out, and then the remaining piece, the piece that I pull out of the a squared, what's remaining is just going to be an a. And you can test it out for yourself. If you multiply these two things together, you're going to get an a squared. Okay? Now what about the second piece? If I pulled an a out in front of an entire expression, what's remaining in a 4a? So if I take an a out of the 4a, I'm left with a plus 4. Okay? And again, if you want to check yourself, you can multiply this across, and you'll see that it equals that. Now we're going to do the exact same thing here. Now the only difference is that we've got an a times a b, and the second piece is a 4b. So the b part, we can pull that out in front, since this is in both of those pieces. Again, we're just looking for what's in both pieces. And now notice what we have. The a plus 4 and the a plus 4 in the denominator, these match up, which means we can actually cross them out, and the only thing remaining is going to be the a over the b. Okay? So that right there is our solution. Now I'm going to jump to question 30. There's a couple questions in here that require quite a bit of factoring, and so I'll forewarn you, this is actually one of those questions that we're going to look at right now. Let me take a drink of coffee because I'm going to need it for this question. Oh, delicious. All right, 30. The question is x squared plus x minus 12 all over x squared minus 6x plus 9. Now, I'm going to go the fast way, and I'm going to show you the slow way, the way to work it out. I think it's really helpful to get a grasp on factoring in this class, because it will help you if you can really learn to master it. I think I've hammered that point a few times, actually. So here's what we're going to do. We're going to do the factors just like we did in the previous chapter. So remember, we do a times c, so a is 1, c is minus 12. In this case, it's just going to be the minus 12, okay? Because a is 1, c is minus 12, 1 times minus 12 is minus 12. So we need to find all of the factors of minus 12, okay? So the product of minus 12, let's just break it apart. Minus 1 times 12. This is going to be 1 times a minus 12. Other factors are going to be negative 2 times 6, 2 times negative 6. This is going to be a negative 3 times 4, and a 4 times negative 3. Or, sorry, hang on. I just did that. Negative. So a 3 times a negative 4. There we go. All right. And now we are done with our factors. So now that we've got the product, we want to find the sum of those individual factors when we add them all up. This is going to be 11. This is going to be a minus 11. This is going to be a minus or positive 4. This is going to equal minus 4. This is a positive 1. And this will be a negative 1. Now this number is important right here because we need to look to see what the coefficient of that middle term is. And that's going to determine what our sum is that we're going to use. We want it to be equal to whatever that coefficient is. So I've got 1 right here. This is the one that we're going to use, which means my factors are going to be minus 3 and 4. So I can rewrite the numerator as x minus 3 times x plus 4. Okay. And as you start doing this, you'll really start to do it in your head a little bit more quickly. What I generally try doing is I'll look at the minus 12 and I'll just think of the numbers and the combinations of those numbers that would add up to equal whatever that number is in the middle. So 12, I know the factors are 12 and 1. 6 and 2, 4 and 3, I won't even think of the signs, okay? I'm not going to even think of the positive and negative signs at all. So the factors of just positive 12, of just 12, are going to be 1 and 12, 2 and 6, 3 and 4. Some combination of those numbers will give me a positive 1. Well, I know it's 3 and 4. They're just 1 separated by 1. And then if the number here is positive, that means the bigger number in those factors is also going to be positive. So actually it produces exactly the same thing that I just did. I just did it in my head a little bit quicker, right? The bigger number, or the bigger digit is going to be positive. The smaller digit is going to be negative. So let's go ahead and do the bottom one. I'll do it the longer way, and then I'll show you the quicker way. I'm just going to process it in my brain out loud so you can kind of follow along with me. All right, so we've got 9. Here's product. And here's our sum. Okay. So for 9, this is actually a pretty straightforward one. It's just going to be -1 times -9, 1 times 9, 3 times -3 times -3, and 3 times 3, and then we add these all up. Okay, and we're going to get a -10. This will be a +10. This will be a -6 and a +6. Okay. So now I look at, again, the middle term. It's going to be a -6, so I have to use, I'm looking in the sum column for -6, which means these are going to be my factors. So I'll have x minus 3, x minus 3. All right, so let me go through the mental way that I would do it. So 9, the factors I know are going to be 1 and 9 and 3 and 3. Again, I'm not thinking about the sign at all, just 9. 1 and 9, 3 and 3. Any combination of those numbers that's going to produce a 6, well, it would be 3 and 3. So because this sign's positive, I know that either both have to be negative or both have to be positive. And since this sign in the middle here is a negative sign, then both signs have to be negative because I'm going to add them in the middle. That's a sum. Okay? So that's where I get the x minus 3 and the x minus 3 from. So again, I wanted to kind of walk through my mental process with you so you can hopefully see it. A lot of this is just a puzzle. Oh, you know what? I didn't finish the problem. I just erased it. Well, I'll just write out what we had. Okay, so we had x minus 3. I got so excited about the factoring, I just decided to continue because I just want to keep doing more factoring. X minus 3 times x minus 3. Okay, this is what we have. So now what we're going to do is we see that there's an x minus 3 here, an x minus 3 there. These aren't the same factors, so we can't cancel them out. So our final answer is going to be x plus 4 all over x minus 3. And that's our solution. All right, so that's how you do that one. Let's go ahead and jump to another question. We're going to have a few of these. When we do these bigger ones, the ones that have, the trickier factoring, where it's, there's an a term that we have to work on. So a coefficient in front of the very first term. I think it's important that we do the tried and true way that we've worked on before. So 6x squared minus 7x plus 2 all over 6x squared plus 5x minus 6. Okay, this is going to be a long question. And the reason why is because I've got two pieces that are both kind of crazy factoring. So let's just work on a piece at a time. Okay, we'll do the top piece. So remember, we do a times c, that's going to equal 6 times 2, which is equal to a 12. And now I'm going to find the factors of 12. So we've got 12 is equal to, negative 1 times negative 12, 1 times 12, 2 times negative 6. I'm going to try to go in the same order as above. 2 times 6, negative 3 times negative 4, and 3 times 4, positive. So now when I add these together, now you'll notice I don't have the sum and product thing. I'm hoping you'll understand what I'm doing when I do this, okay? This is going to be a minus 13. This is going to be a positive 13. Minus 8, positive 8. I'll put the positive sign there. It doesn't make a difference. Minus 7, positive 7, okay? So that was for the 12. Oh my gosh. Yeah, okay. Yeah, we're right. Sorry. Okay, I thought I made a mistake. I did not make a mistake. We're good. So here we have these pieces. So remember, when we factor, we're going to do it by grouping. When we have something this complicated, we do it by grouping. So first, let's find what that middle is. This is a minus 7, not a 2, just so you're aware. Which means I'm going to use this guy right here and these two factors. So we've got 6x squared minus 3x minus 4x plus 2. Okay? And now this is equal to, let's put our brackets around everything, 6x squared minus 3x. So we're only going to deal with the first pieces and the second pieces. Now here's where it gets tricky. Because I've got a minus sign here, if I pull a minus sign out in front, so say I'm going to pull out that, this has to turn into a 4x minus 2. And the reason why is because that minus sign, if you think about it, it's going to go to the 4x, but it's also going to go to the 2. Because I know my original was a positive 2, then I have to have, it's like a negative negative right there. So this sometimes will trip people up, but I encourage you just, if you get stuck, just multiply it out to double check yourself. So now we're going to factor pieces out of these. So what's common in both of these pieces right here? My brightness is getting a little bright. Let me turn it down just a little bit. And there we go. It's a little bit better. So what do we have? So this, it looks like we're going to have a 3x that can be pulled out in front. That's a 3x. Times 2x is going to be remaining here. Minus 1. Because we pulled the whole thing out, so there's only a minus 1 left. Now, over here, what can we pull out of these? Well, it looks like for the 4x and the 2, just a 2 can come out of both of those. So we'll do a minus 2 there. And this will be a 2x minus 1. And when we get down to something like this, we want to make sure that these two pieces are the same. So now I can combine the things that are circled here and the things that are underlined there. So this will be 3x minus 2 times 2x minus 1. Okay, so that's just the numerator. This is going to be a long question, right? 3x minus 2 times 2x minus 1. We're going to divide by. Let's go here. Now I'm going to work on the bottom, okay? So we'll erase this whole thing now that I've got that part. Oops, lost my pen. All right, so now we'll do the bottom. A times c is equal to 6 times negative 6, which is equal to negative 36. Yikes, that's a lot. Okay. Negative 36. Let's work on the factors. So we're going to have negative 1 times 36, 1 times negative 36, negative 2 times 18, 2 times negative 18, 3 times, negative 3 times 12, sorry, 3 times negative 12, Negative 4 times 9, 4 times negative 9. I don't know if I ever communicated this to you, but the reason why I think I got so good at multiplication and finding factors is because when I was in like 3rd or 4th grade, I was pretty naughty. I was one of those kids, and one of our punishments was that rather than having recess, we had to do multiplication tables, and did a lot of multiplication tables. So I pretty much have had it memorized since like 3rd grade, which is why I'm going through these so fast. It's just one of those fun little things that you pick up even though you're in. I guess they took something that was negative and turned it into a positive for me because hey, I made a nice job out of it. Who knew multiplication tables could get you a job? Okay, so now let's add these up. This is going to be a 35, positive 35, negative 35. 18 and negative 2 is going to be a positive 16. This is going to be a negative 16. This will be a positive 9, negative 9, positive 5, negative 5, and this will be 0. We know it's not going to be that because there is a middle term. So we're looking at 5, positive 5, right? That's what we're looking for. So it looks like positive 5 here. These are the factors. Okay, now we do the grouping. So we've got 6x squared minus 4x plus 9x minus 6. Okay, so we put the brackets around everything. 6x squared minus 4x plus 9x minus 6. Sorry, my sizing is getting a little crazy there. Just zoom in really tight. So let's look at what's common in both of these. We know there's an x in both. There's an x squared there and an x, so we can pull an x out. There's also a 2 in both of these. We can actually pull a 2 out of a 4 and a 2 out of a 6. So what's that going to look like? The 2 is going to come out, the x is going to come out, and what's remaining? 2 times what is equal to 6? Well, that would be a 3. There's an x remaining, we already said that, and then now, for this piece, 2x times what is equal to a negative 4x? That would just be a negative 2. Okay? And here's the cool thing. We have a positive sign, so we don't have to worry about that whole negative nonsense that I was talking about last time. 9x and a 6, negative 6. We can actually pull a 3 out of both of those. So let's pull a 3 out in front. And then I'm going to be left with 3 times what is equal to 9x? That would be times 3x. 3 times what is equal to a negative 6? That would be a minus 2. Okay? So now, I'm just going to put it in here in the fraction because I'm running out of room. The 2x and the 3 and the 3x minus 2 are all going to be multiplied out. So this is going to be 2x minus or plus 3. So the parts that are sitting in front get merged into their own factor, and then the pieces that are right here are going to be also merged together. So check out what we have. That's a very long question, as you can tell. This guy's going to go away, that guy's going to go away, and we're left with a 2x minus 1 all over 2x plus 3. Okay? Long problems. As you start getting a little higher in the math classes, the problems you have to work out get a little bit longer. That's why I really am trying to push doing the mental math as much as I can, because the more you can, learn to process it internally, it can really help you and just help you work through some of those things a little bit more quickly, so you don't have to write them out. All right, so now we're going to do a multiplication one. So this is going to be 3x squared plus 2x all over 3xy minus 3y times 3xy cubed minus 3y cubed all over 3x squared plus 2x squared. Oh, this is cubed, sorry. I knew I was making a mistake there. This is going to be a cubed. Okay. So that's a cubed. We've got that. So what do we do when we deal with this? We're literally just going to multiply right across the board. So what you can do is you can just merge it all into a single fraction. What I'm going to do is something a little different in this case. You can do that. You can multiply it across and turn it into its own fraction. It's a single fraction. I'm actually going to factor each of the individual pieces. So the numerator of this piece and the numerator of that piece, the denominator of this piece, the denominator of that piece. Okay, we'll do them separately. So let's take a look at this. Again, we're going to work on the mental side of things. 3x squared plus 2x. What do you see that is in common in both of those pieces? You see an x. There's an x squared here and an x there. So we're going to pull the x out. And what's left is just a 3x. We're going to reduce that down by 1 plus 2. Okay? Now let's work on the other piece. What is common between both of these pieces here? Looks like the 3 is in both pieces. It looks like there's a y to the third in both pieces. So we'll do a 3y to the third times, well, what's remaining? What didn't we pull out? An x. What about over here? We pulled everything out. So the only thing that's left is just that negative sign, and it's just a negative 1. Okay? So now let's do the bottom piece. Again, we're doing the whole thing separately, and I'm kind of converging them all into a single fraction. Again, you can do that. That's fine. 3xy minus 3y. It looks like a 3 is in both pieces. There's a y in both pieces, so we'll do a 3y in front. And what's left is an x and the minus 1 times over here. Doesn't look like I can do anything with the 3 or the 2 because they just don't work into each other. You know, one doesn't divide into the other one. But there is an x cubed and an x squared, so I can actually pull 2 of those x's out in front. Or an x times an x, I should say. So that would be an x squared. And we'll be left with a 3x plus 2. So now look what happens. We have this all as a single fraction. I've got the 3x plus 2 and the 3x plus 2, those go away. The x minus 1 and the x minus 1, those go away. I'm going to rewrite this out, okay? Usually I just try getting rid of those big factors first, and then I just remain or keep the smaller pieces into its new piece. So x times 3y cubed all over 3y times x squared, okay? So now, take a look at this. I've got an x squared in the denominator and x in the numerator. If you remember the rules of fractions, this is the same thing as x to the first minus 1 minus 2. The minus 2 comes from the denominator because that's an x squared. And then we have a, the 3's are going to cancel each other out. Let's just get rid of those. And I've got times y to the 3 minus 1. Now that equals x to the minus 1 because I can just add those up together now. And then this is going to be y squared. So because this is a minus 1, it's the same as 1 over what that is. So we're going to have y squared in the numerator because that's a positive sign. And in the denominator, we're going to have an x. All right. So that's how you go about working on that problem. Let's do Let's do a couple more. I know this video is getting a little long, but I really want to get through these because I think it's good just to have a good slew of examples. You can always go on YouTube as well. There's a ton of examples out there. I think that they'll be really helpful for you. So let's take a look. 6x cubed plus 7x squared all over 12x minus 3. Now we're doing the division. Divided by 6x squared plus 7x all over 36x minus 9. Wow, okay. So first I want to rewrite this. I'm going to completely rewrite this. We'll take the first part just as it is, plus 7x squared all over 12x minus 3, and we're going to multiply by the flip. So we're going to flip this. We're going to take the reciprocal and multiply it. So this will be 36x minus 9 all over 6x squared plus 7x. Okay? And now we do exactly what we just did the last question. We're going to do each individual piece. So we've got a 6x cubed and a 7x squared. I'm going to pull out an x squared in front, and I'm going to be left with a 6x plus 7. For the bottom, I can pull a 3 out of both the 12 and the 3. So this will be a 3 times 4x minus 1. And then over here, I can pull a 9 out, and I'm going to have 4x minus 1 as well. And I can pull an x out here, and this is going to be 6x plus 7. Okay? So take a look at what happens. That cancels with that. That cancels with that. And I'm left with x squared times 9 all over 3 times x. So that means I've got 3 goes into 9 3 times. X goes into x squared once. So you can, again, if you want to think of it like this, you can have 9 over 3 times x to the 2 minus 1. And that's going to be 3 times x. So that's our final answer right there. All right, one last question. Now I am going to go through, earlier I mentioned how I'm taking a lot of time to go through these factors, okay? I'm going to go a little faster on this last question. I'm going to leave it as an exercise to you. If you don't know where I'm getting these factors from, I'm going to leave it as an exercise to you to actually work through the factors on your own. Okay, we've done a lot of examples of them up to this point, so I'm going to leave it to you to go ahead and do that because there are questions on the homework that require you to do the factoring. So question 78. I've got x squared plus 2x minus 15 all over x squared minus 4x minus 45 divided by x squared. Lots of factoring going on here, as you can see, all over x squared minus 5x minus 36. All right, so first things first. Well, I'll put it down here. Division sign means we flip it and we multiply. So x squared plus 2x minus 15, that comes along for the ride. X squared minus 4x minus 45 times, flip it, x squared minus 5x minus 36 all over x squared plus x minus 12. That little dot went in there somewhere. Okay, so that's what we have. Sorry if I'm a little messy because I'm a little excited. This happens. All right, so like I said, I'm going to do the factoring a little fast on this one. Try to follow my thought process as I do this. We're going to go each piece at a time. And what we'll do, again, if you want to understand my thought process, but you're like, whoa, you're going really fast, hey, take that little speed on YouTube and drop that puppy down to 0.25, and you can hear me go in super slow motion if you need to. Okay? All right, so here we go. Let's do the first piece. We've got a minus 15. So let's just think about 15. 15 has a few different factors. It's got 1 and 15, 3 and 5, and that's pretty much it. Okay? So a combination of 3 and 5 is going to produce a positive 2. Again, I'm just kind of talking this out loud. Combination of 3 and 5 is going to produce a 2. Okay? This sign is negative, that sign is positive, which means the bigger number is going to be positive. So 5 and 3, so this is what it's going to turn into. It's going to be x plus 5, x minus 3. Okay? All right, so now let's do the bottom one. 45. All right, so we got 1 and 45, 3 and 15. That is not going to give me 4. What else we got? 3, 4, 5, 5 and 9. 5 and 9. Combination of 9 and 5 will give me 4. This is a negative sign, which means that the bigger number, the 9, is going to be negative, and the 5 is going to be positive. So this is going to be x minus 9, x plus 5. Okay? Hopefully you can see how I'm processing all this. Even though you can't see my face, you can hear my voice in your ears right now, helping you process. All right, let's do the next piece. 36. We got 1 and 36, 2 and 12, 3 and... Oh, I'm sorry, not 2 and 12. It's 2 and 18, 3 and 12, 4 and 9, and that is going to be our number. 4 and 9. Okay? 4 and 9, a combination of 4 and 9 will give us 5. The 5 is negative, which means the bigger number is going to be negative, so this is going to be x minus 9, x plus 4. Okay? I hope you can see how I'm doing this, or at least think to see how I don't know how to say that. Okay, let's just keep going. Minus 12. 1 and 12, 2 and 6. No, that's not going to give me a 1. 4 and 3? Yeah, 4 and 3. So that's a positive, that's a negative, which means the bigger number is going to be positive. So the 4 is going to be positive. So I have x plus 4, x minus 3. Okay? So that's actually how I just did all the factoring right there. Again, if you're like, whoa, you went so fast through that, I'd suggest you can go back and go through just like we did in the last few sections, write out the product of every single one of them, and then write out the sum, and then find your factors, and you will get exactly the same answer that I just got right here. Okay? I'm going a little fast. I understand that. I don't want this video to be over an hour long. Otherwise, it would be, okay? We're approaching the 50-minute mark here as it stands. So, all right, what do we got? Let's do, so the x plus 5, x plus 5, x plus 4, x plus 4. Again, this is multiplying, so again, you can think of it as being in the same fraction. X plus 9, or minus 9, x minus 9, x minus 3, x minus 3. What's left? Nothing is left. So here's what you should not write. Do not write 0, okay? It is not 0. When everything divides itself, you're left with a 1 over 1, which is equal to a 1. That's it. That's an annoying problem. They put so much work on you, and then the answer is just 1. Crazy. Okay, so that's how you go about doing it. Again, factoring just a little bit quicker. You can go back, and if you want to review how to do the factoring a little bit more, just for practice, I'd encourage you to go back and check out some of the older videos. But aside from that, that's all we have today, and I hope you have a fantastic evening.